Yes, yes.
No. Yeah. Thank you. So, hello everyone. My name is Mohammad Kafil Khan, and today we are having session on DevOps and its basics. So, I'll be covering very basics things regarding DevOps. I will be talking about DevOps, what is DevOps, what works we do in DevOps, and many things like I hope many of you are freshers here and are in the college. So I'll be talking how to get into the DevOps as a fresher, and what are the technologies you need to learn to get into the DevOps or in the cloud field. I'll be also talking about the cloud very basics, and I think in deep Pranay bhai will go in that. And apart from that, I will also be talking about Docker little bit, and yeah, and last about my journey, how I got into the DevOps as a fresher. Yeah. So a little bit about me. My name is Mohammad Kafil Khan. Right now, I'm working as a DevOps engineer at Samsung R&D Noida. I'm also working as a co-organizer at GDG New Delhi. I hope you all know about GDG New Delhi. I'm working there as a co-organizer. Yeah. So let's start. So what is cloud? So I will start with basic things like what is cloud. So basically, if we discuss about cloud basically refers to the server that are accessed over the internet, that are the things that we can access with the internet. And with like we have a laptop here, and if we want a server on the cloud, we just need to create a server on the cloud. Like we are having many examples there, like we have AWS or GCP or Azure. We can create our machines there. Like you can say you are creating your own laptop there, you are creating your own machines there. So this is the, with the help of internet, we are doing the same. Like it is very helpful that we don't need any physical servers right now. So basically we can do everything on the cloud, and we don't need any physical server. So where is cloud? Yeah. So where is cloud? So cloud is nothing but our servers that are provided by the companies, big companies like Amazon, Google, or many other companies like Dissolution provides. They are having a different servers on a different locations. They have, like Amazon have a data center on the Mumbai. So if we are creating any server, we are taking just tiny part from the data center, like in Mumbai or in anywhere, like US they have in Europe. So we are taking that. So if I talk about data centers, how they look, how the cloud is look. So this is the kind of data center that I these are the pictures that I have taken. So these are the things that are data centers that are from Google. I have taken the pictures. And yeah, now let's get to the point. What is DevOps? Anyone wants to tell anything about this? Any have any basic idea? Anyone? Okay. So let me tell you that basically, if we talk about DevOps, so many people say, means right now DevOps is on the boom. Like everyone talking about cloud, DevOps, Docker, Kubernetes, and Ansible, Terraform. Many technologies are there, and everyone is talking about that. So let me tell you, DevOps is not a new tool or technology in the market. It is nothing. It is not a new tool that anyone is working. So just to clear, it is a new culture or process to develop, release, and maintenance of software with higher quality in very fast way. Just to repeat, it is a new culture or process to develop, release, and maintenance of software application with higher quality in very faster way. Okay, and we can achieve this by using automation tools. We can achieve this by using automation tools. For any software product, two groups of engineer will work. Like if we see DevOps, it is basically development plus operations. So if we talk about any software, like development groups and operations group, so can anyone tell who are the people that work in development group? Anyone? What are the process, or who are the people are there in development group? Anyone? Am I audible? Piyush?
Yeah, yeah, Bhaiya, you are audible.
अरे चिल रहो भाई, मतलब you can say anything. Let's make it interactive session so that you guys can learn and I can also learn. You can tell what do you understand by development group, or what do you understand by development? If I talk about that you are developing something, what do you understand by? Anyone? Arey, you can write on the comment box also. I think,
I guess few people have write like a
yeah,
new who's writing developer programmer.
yeah. Anyone else?
Guys, don't be shy.
Yeah, yeah, because yeah,
forming the forming the
yeah.
association of
Okay.
group.
Anyone else? So thank you, whoever said that. So basically, development group is a group that is required for the development. So we can say we have a different groups in the development group. Like we have a if any requirement, like if we have application, like suppose we are creating application for Samsung S20s. So there are many things that basically initiate from the initial process. Like we have a business analyst that takes the requirement and understand everything. Then we have a system analyst who takes the requirement from business analyst and create the wireframe or the different things from there. Then we have a design architect who create the design of the application. After that, we have a developer coders. I hope many of you are here who are developers and coder. After that, there is a build engineer who create the build for the same. And after that, there is a test engineer, that is QA, or there is a testing person that is required for the same. So these kinds of role that all this come in the development group. Okay, so these are the roles that comes on in the development group. Now there is a operations part came in the picture. And the operation part required, like we have in development, if I want to declare, so the people who are involving in development group are basically for planning, coding, building, and testing. And now if we talk about operation group, so the people that are involved in are basically for release, deploy, operate, and monitor. So if the application is developed, we are planning for release, that we are going to release the application for the people, like for us. After that, we are deploying the application, that we are deploying this application on this server, on that server, and so that people can view the same. And we need to operate the same, that how does things are work. And after that, we need to monitor the application, that how the application is performing on the server. Is we are getting any error there or anything like that. So this is the so basically, DevOps is a culture. So basically, the main objective of DevOps is to implement collaboration between development and operation teams, basically. So if it see, like plan, code, build, and test, these are the things that the development group works. And release, deploy, operate, and monitor, these are the things that operations team work. So DevOps basically is a combination of development and operations. So they work with them and create a faster life cycle of any software, basically to create a high-end application. And with the help of automation tools, if we talk about DevOps, automations played a very important part, and very uh, important part, that it helps to deliver our software very fastly. Like if we talk about Jenkins, so with the help of Jenkins, we deploy things very fastly. Like it is a CI/CD tool, so we continuously deploy and application and deliver it to the application, to the client, and he tells to us that what are the requirement are there to changes frequently changes to be done. So this is very better to the agile or waterfall model. So what are the DevOps area? We have a CI/CD, that I told you, that Jenkins basically I use for CI/CD, or we use for CI/CD. In Samsung, I am using Quick Build for the same, that is a paid tool. But Jenkins is a open source tool. So basically, everyone in the DevOps is using Jenkins mostly for CI/CD tool. So let me show you some examples of Jenkins. Mm, yeah. Is my screen is visible to everyone?
Yeah, you are visible.
Yeah. Anyone have any question as of now? Anyone? So basically, this is a AWS console. Uh, I will be using AWS for the demo. So basically, this is a EC2 instance. So we will be creating a machine using EC2 instance, and yeah. So I have already created a machine, and Jenkins is running on the same. So let me show you how we create servers on the cloud for the DevOps or any perspective. So basically, we are creating a machine. So you can take we are taking a computer from a shop. So there are many options we have, like which operating system you want. Do you want a Red Hat? Do you want your Ubuntu server? Do you want a Microsoft server? Do you want a Microsoft? And there are many servers, like we have many things. So I will be taking a Ubuntu machine for our example, and then we have a like instance families. What kind of instance families we have? So there is a T2 family, and type is T2 macro, and we have one CPU and memory is 1 GB. So there are many families we have. Like T3 dot large, we have a 4 CPU and 16 GB of RAM, you can say. And like on we for free trial, we have only T2 dot micro. For other of the like instances, we will be having a we need to pay a huge amount for that. So I'll be taking a free machine. So let leave it as blank. Then we have a storage, like you can say your hard drive, you can say. So we will be taking a default 8 GB. And tags is basically, you can just say like for clearance of everyone, that name is like testing. Yeah. Again, security group is one of the main part. Like we are securing everything from out of the world. Like if you are creating an API or database, it must not be visible or accessible to the world. And if you are creating a web application, then it should be accessible to the world within a limit. So that there are many other challenges that we get while creating an application. So we always need to take care of the security group. So we'll be taking a default security group, means it is accessible to everyone. Yeah. So these are the basically review that what we have done. Basically, we have a Linux machine, and we have an instance type and security group. These are the things that we have created, and we will just launch an instance, and we need to select the key pair. This is another level security that we are getting uh, from cloud, that we must have our key, else we won't be able to connect to our instance. So like I have created an instance, you know every detail. If I will create the instance, you know everything, like this is the public IP of this server, and this is that, this is this. But you can't connect to the machine because you won't be having any like key of this server. So this is a next level security that AWS or GCP like other clouds provides to us. Uh, yeah, let me connect with this. So when this, yeah, this one is created. So this is the public IP that we have got from this, and we can connect with this using SSH command. So we need to first to go to the downloads one, set hyphen -a. So we are telling them this is the key that that we have used for this server, that is this IP, and the username for this server is Ubuntu. Yeah, so we are inside the server, like we are inside the server. If we click on this server, like we have nothing, we won't get anything because we don't have anything on this server, and we have not installed anything. So if we just install, just to show you guys, we'll just update the server. Yeah, it has updated. So I will install a web server, that is Nginx. Yeah, sorry, that is yeah. So basically, web server is required for to make our website visible to the world. So I will be installing just a web server to show you guys how the configuration of any website we do in the DevOps. Uh, yeah. So our web server has been installed. So if we now click to our that IP, that public IP that we have done, so you can see here that welcome to Nginx, and the details that default is that it has provided. So now with the help of this web server, you can deploy on this server. You can deploy any application on our server, like you have an Angular demo application, or you have a React application, front end application that I'm talking about, because for that we basically use web server. So if I just show you that where our deployment has been done, uh, so you can see a file here that is index.nginx debian.html file. So if we just get this file, you can see that whatever it was showing, you can see here the data is there. So if I just remove this file, mm, and let me create a new file, name index.html, like welcome to Enterprise from Club Uncle Gotia. Escape button is not working. Oh, why this now? Mm, I think I need to connect to again the server. My escape button. It's not working. Sorry, I just need to connect to again. Let me see. Downloads. SSH hyphen. Okay, so we are going again. I guess this time I will use nano editor to create index.html file. We'll just write welcome to DSC Galgotia. So yeah, if I just check that index, so there is a file that we have created, and if you just refresh this, you will get welcome to DSC Galgotia. So this is the path where our means build file is stored. Like you have created a Angular application. So if any of you are working on Angular application, so you guys must be knowing that with the help of ng build command, we create our build file for Angular application, and so we put the build file on this path, and after that we can just deploy our application, and our Angular application will start working on the from the same path. So what is the requirement of DevOps here? Like CI/CD, continuous integration and continuous delivery. Like suppose I have created this thing like welcome to DSC, and after that, like Piyush is a DevOps guy and I am a development guy. I have developed this, and I have asked Piyush to deploy this application. Piyush, please deploy welcome to DSC, and he will just deploy that yeah. Kafir, I have deployed the same. After 1 hour, I have done the changes on this file. Like I have added the background and I have added the new thing. After that, I will again ask the Piyush that Piyush, can you please deploy again, and I need to show to the client. So he will again deploy, and after again and again I will be asking Piyush, so he will get irritated, or I can say that it is just hampering one resource of ours by asking again and again, doing the same work. He's not learning new thing, he's just doing the same work again and again. So with the help of CI/CD tool that like Jenkins, we can perform these tasks from that. Like just to show you, uh, so I have installed Jenkins already here because it, yeah. So just to show, yeah. Here we have a this is the Jenkins dashboard that you can see. You can create any application from here, like pipelines here. So I have created a folder test, and in that I have created a test pipeline. So I just configured a GitHub repo here to show a demo that we can get frequent changes from here, from GitHub to here using. So I just let me just open my GitHub account. Any question, guys? As of now, anyone have any question? Anyone? Okay, let me exit from this here. I'm on the Jenkins server, and I have this folder called test. Yeah, sorry, this is a folder test. So basically, this is a repo that I have here, like on my GitHub profile, and I have just created like welcome to DSC Calcotia, and these are the changes that I have done. So let me configure the CI/CD pipeline of that, and I have already configured that. Like if I will show you, yeah, these are the things that I have configured. Let me delete it, and I will create, let us create a freestyle project, and I will just say the restaurant club. And yeah, I create a freestyle project for that, and we are configuring like git for this. So I will just, we just need to take our clone path from where we are taking HTTP path for this. So we just need to put here, and after that we need to put our credential for this so that it can verify the same. So I will just take this credential. How to add the new credential? You can just go to the Jenkins and you can put your username or password, or we can also do these things using SSH username private key for that. So you can just and put our like this is the branch name that we are using for CI/CD. Like the branch that you will specify here, the CI/CD will run only for the same. Like if I will push the changes, like Piyush has told me that Kafil, I have done the CI/CD of your application on the main branch. So whenever I will push any code on the main branch, it will run the Jenkins pipeline and it will display the changes on our server. Like if I will push something on the development branch, it won't show anything on the server because we haven't created pipeline for the development branch. So this is the thing. Yeah, we will just apply and save. And if I just run this, yeah, the it is success. So we can know that our path, our new code has been here, that we can check on the server. Like let me show you. So you can go on this path and just you can see that there is a changes, like there is a file that, and all the changes are here that we have on the GitHub. So let us change the file, let's do some changes on the index.html file here. Let's do that, like let's welcome to Galgotia and remove everything. Yeah, we have done the changes. Yeah, let us run the pipeline again. Same path. You can also check the code from here, that your workspace. We have got the updated code here. Yeah. So this is how our CI/CD tool works for any applications, like for any of the application, like we have applications of Angular, React, Java, PHP frameworks. Any application you can create the CI/CD for any of the application. Any questions as of now on this? Anyone have any question? Or you can put on the chat box. So basically, Danish is asking about Jenkins versus Elastic Beanstalk plus code pipeline. So basically, both are very different. Danish, basically, Jenkins is open source CI/CD tool that we basically use, everyone use, and Elastic Beanstalk is a kind of server. It's a server machine that like we are using EC2 instance. It is a, but in EC2 instance we manually have to do configure everything. Like I was showing that we need to install Nginx. If you are deploying Angular application, you need to install Node first, then we have to install and like Angular software, and then we need to deploy everything. But Elastic Beanstalk, everything is configured. You just need to deploy your code there, and it will deploy your application on the server. And the code pipeline, basically it is also a CI/CD pipeline that is given by the AWS. If you are basically, code pipeline is very helpful if you are using everything of AWS. Like we have a, like I was using, I have configured a software that is of application that is Nika. If you guys know about Nika, I have configured the same. So we were using everything on AWS. Like we are using EC2 instance there, like we are using load balancing, auto scaling, everything on AWS. So for that, we basically we were using code pipeline, because code pipeline was very feasible and very easy to use, compatible to use with the AWS softwares. So basically this is the difference that I know. Anyone have any other questions? So yeah, how OpenShift is related to Jenkins? No, no, no. Both are very different. Basically, OpenShift is a family of containerization software product. It is developed by Red Hat. Like if I will tell you container service, like I'll be going telling you basics of Docker. Then I think Pranav, I will be more telling you on Kubernetes. So basically, OpenShift is very different from Jenkins. They are not related to each other, and they are not. Yeah. Gajanan is asking, it is necessary to learn cloud if I want to start with DevOps? No, Gajanan, I don't think it is important or necessary to learn about DevOps, cloud to learn about DevOps. But it is, yeah, for now, it has become a culture to people learn about cloud while going to DevOps. But cloud is very different from DevOps. DevOps is totally different. But yeah, while initially I was working in a service-based company, and yeah, so there are clients that basically want cloud services and DevOps guy in the same. So basically that's why we were doing the same. So I think Piyush, we can take the question at the end. I can move forward because I think we just have 10 or 15 minutes.
Yeah,
Piyush?
sure. Yeah,
Yeah.
sure.
Yeah, so let's talk about Docker a little bit. I have shown you the demo of the cloud and the DevOps things that I think you will get the basic understanding. I hope you have understand or got the basic understanding of the DevOps, what we do and how we function. So basically, these are the DevOps area: CI/CD, provisioning, deployment that I have showed you. DBA, like database administrator, we configure the database and deploy the things. Performance is one of the most important part in the DevOps area. Like performance and deploy is the key thing that we do. Like our application performance is always checked with like continuous testing, monitoring, alerting. We always check. Like monitoring is also one of the main part after, like our DevOps work is start when the application is developed. Like we work at the initial level, but our main work start when our application has been successfully deployed and the users are using. We continuously monitor things, that how the our applications on reacting on the login page, on any other page. If you are using selecting any like product, you are shopping on the Nika, if you are selecting any product, like we monitor everything. Whenever we do a live session with anyone or Nika, we were monitoring everything on the we were using Zabbix there, that to monitor our application, that how our application is performing. Alerting, like if you are getting any error, like suppose we have a big billion day and we have a then we have a very huge amount of people coming on our shopping website. So we always have alert that if anything is going down, or if you are facing any error, if our database is reacting right, or if any we got any uh, like failure on anything. High availability is very important. Suppose we have a big billion day sale, and we have created a machine, and the machine got stopped. We have taken a server. I have created just EC2 instance, and we have deployed a DSC Galgotia website. So suppose we have some event is going on, and everybody is checking our website, and our website got down. So this must not be the case when we are using DevOps, cycle or architect DevOps things. So basically, high availability we can get using auto scaling, load balancing. These are the main things. These are other things that you can learn on the cloud part, or when we talk about Kubernetes part. And disaster management is one of the important part that plays into the DevOps areas. Like I told you that we have a different data center that cloud provider provides. We have a data center on Mumbai, we have a data center on US. So if something occurs in Mumbai, so our data, so this must not be the case that if something occurs in Mumbai, there's a flood came in Mumbai. So our all the data is lost, our website is finished. So this must be the also disaster management is also one of the paid part of the DevOps guy. So yeah, let's talk about Docker. So if I talk about definition of a Docker, so basically Docker is a software containerization platform, meaning you can build your application, package them along with their dependencies into a container, and these containers can be easily shipped to run on other machines. So basically, like I showed you that we have taken a Linux machine. I have installed Docker there. Sorry, I have installed Nginx there. So our server, we have for installation of Nginx, we have used our server. But in the case of Docker, we can create a container for the same. You can take we can create container, like you can run command Docker pull Nginx, and it will take the image of the Nginx to our machine. And after that, you can run Docker run command. You can using Docker run, you can run the same. Let me show you. So yeah, let me show you where we get the images. If I just show you like Docker Hub, and let me tell the example of Nginx. So yeah, this is the image of Nginx that we have installed there using the command sudo apt get install nginx. So this is the to get the image, we have to use docker pull nginx. We can pull the image of the nginx on machine using docker pull nginx. We'll get the image, and after that, if I want to run the image, so you can use the command, yeah, docker run hyphen name and the port as 8080, or this is the port that we'll be using, and some context name. You can use the same. So these we are creating a container on a machine. So if I will, this is the machine and I'm creating something, so we can run many machine together. Like we have a, if this machine I will install Angular, like we have a dependency, I want to deploy two Angular application, and one Angular application is having a version of 7.2, and other Angular application is having a version of 8.2. So if on the same machine we need to install two Angular application, so it will be very difficult for us to configure the same. But using Docker, it will be very easy. We can take a image, we can create a container for one Angular application, and we can create a linear image of one Angular application, and we can deploy the same on the same machine. It will be very easy. So basically, it is a container. All the dependencies and everything will be installed on the container. There is nothing. Basically, our machine, that is one the machine, it is just used as a server, nothing on the, it will just use as a Linux machine, that it is taking just on that, the container will be deployed on that. Yeah, about my journey, let's take first our few questions. Yeah, you will be telling, or should I check my own? After that, I think Gajanand has asked, is this necessary to, yeah, how to install Jenkins? Yeah, Abhimanyu, you can install Jenkins just to Google that install Jenkins. Like I have used a Linux server, so I will just use install Jenkins Linux, and you can use any of this like documentation. You can just go on that. and just you for Jenkins, we must have Java 8 on our machine. So you need to install Java 8 before installing anything. After that, these are the commands that you will use, and you are easy to go. Yeah. And but if you want to use install Jenkins using Docker, yeah, you guys must do these things. Yeah, we have a Jenkins here, and you just need to pull the image first. We will need a image that Docker pull Jenkins. After that, there is a command that you can use, Docker run command, and you can just, you are good to go with this only command. uh Piyush, can you please tell me the other questions? Can you please read?
Sure.
Yeah.
Uh, we have we have a question like it is necessary to know development if I want to go to in DevOps field.
Yeah, this is a very good question. So basically, there are many people that who say that if you don't know coding, you won't be able to do anything in our field. Many of you, some of you, or many of you maybe not interested in the coding part, development part. You guys must be interested in some other part. So yeah, in DevOps, it is not necessary to be a very hardcore coder, but yeah, it is always not good, very good to be a good coder, but yeah, it is not required to be a very hardcore coder. You need to have a brilliant thinking skill that you can develop configuration. You need to have a architect mind that you need to develop application. Like if I told you that Piyush, we are planning to create a Flipkart, like what things we need to configure and what are the things that we need to do on the server part. So Piyush will be telling that Kafil bhai, we can do this, we can do this. So like basically in DevOps you'll be needing a coding skill for the automation part, like for the script. I was using Jenkins, so there are the groovy scripts we need to write, and or you can say we need to write something on shell script. So you'll be needing Python, groovy script, and basic of shell script you'll be needing.
Okay, I hope it answers to Ankit. Next, we have what is the difference between CI and CD because many people use both terms interchangeably.
Yeah, so basically CI/CD means continuous integration and continuous delivery or deployment. So continuous integration, we are continuously integrating our softwares. Like what I showed you, it is continuous integrating. I was just integrating the software on the development. You have created a DSC Galgodi website, and you just are three people who are working on that, and you just need to continuously integrate the things. You'll be deploying the things. But when I talk about delivery and deployment, we are doing it on the production. We are delivering the something on the production. We are doing we have a mobile app. So like I'm using a APK file, and I just need to deploy every updated version on the Play Store. So I can configure everything on the Jenkins that whenever our APK is created, it should get a signed version, and it is directly go on the Play Store and it get delivered. So it is kind of CI and delivery, CI/CD continuous delivery we are doing.
Okay, we have next question. Continuous integration and continuous deployment. Okay, that hope.
Yeah.
CIC. How can I create my own Docker image?
Yeah, you can create your own image. You can write your Docker file using yeah, you can just write Docker file, and there are many commands that we use, like from, and yeah, from that you can create your own containers and files from here.
Okay. Uh, okay, so moving to the next, yeah, let's hear about your journey, how you get into DevOps and
Yeah, so basically, I graduated in 2018 from Jamia Hamdard, New Delhi, and initially, I have joined Daffodil Software as a software engineer, and I was on training on STML. I still don't know HTML because at that time I used someone else code to show my task. So I have worked on the session on HTML, CSS, and JavaScript initially. After that, I have got the React Native as a language, and I have worked on React Native for around 3 months. I hope many of you must be knowing React Native. Basically, is an Android hybrid application development. We create apps on Android and iOS. And after that, there was a requirement in the DevOps team. We were creating a very new team on our company. So they asked me that if I want to switch on the DevOps field. Yeah, I asked some of the people that I was in contact of the Arpan Bhai at that time. He is the organizer of GDG New Delhi. So I asked him about the DevOps, and after that I switched to DevOps, and I think around 1 year and 10 months I worked on the full software, and I think recently around 6 months ago I have joined Samsung in the DevOps.
That's nice. That might be inspiring to others also. And uh, there's one more question from Lakshay. Jenkins is used to automate OpenShift slash container
Yeah,
tasks.
yeah, we can automate container stuff on the using Jenkins.
Okay, I hope it answers everyone's question. So thank you so much, Kafil sir, for joining us
Yeah,
today and
thank you
sharing
everyone.
such an amazing session on DevOps and Docker.
Thank you everyone for joining, and I hope you guys have enjoyed the session. Thank you everyone. Hello Pranay. Hello Pranay. Hello.
हेलो भाई, कैसे हो?
Yeah. बढ़िया है, आप कैसे हैं?
सब बढ़िया।
Moving on to the next, we have Pranay sir with us. He is a organizer at GDG Cloud New Delhi, and he is a Google Cloud evangelist. Uh, without any, he doesn't need any like introduction in Delhi NCR or in any other place. So over to you, Pranay sir.
Hi Piyush, that was way too humbling of me. Okay, I'll start my presentation. Um, Hi everyone, I'm Pranay. Thank you so much for having me here. It's always great. I have been having people from or students from Galgotia University contributing to the community at large, the entire Google Cloud ecosystem and I like it gives me immense pride when I see them how far they have grown. Like I remember seeing Piyush last year, and then today he's a DSC lead. That's one of these examples. You know how people from this university have been continuously contributing uh, at a large scale and making an impact and a difference. Um, I'm Pranay. I work as a technical lead at Media Agility. Uh, I am also one of the organizers of GTG Cloud New Delhi. So yeah, I start off with my very signature presentations. It's signature because yeah, it's all memes. So I hope you enjoy because I did not want to give like a boring presentation uh, among students. I hope you guys enjoy it. Uh, yeah, I should have changed the title. Sorry, missed that. So yeah, we'll be talking about Kubernetes, and we'll be talking about yeah, how and where did I get here. Uh, just as a brief introduction, what do I do? So I'm a consultant. It's basically that I, in my job role, give a lot of gyan with these organizations, large organizations, small organizations of all sizes have ID problems. And I, in my capacity or my knowledge of whatever I have gained over the past couple of years of Google Cloud or this entire ecosystem, try to solve it using the technologies. And there are also business challenges, there could be technical challenges, and all of it is like being solved on a daily basis using technology. And technology right now is not like, especially in these times, right? uh, it's not. So earlier what would happen, right? Technology would be one center of focus for these organizations. Now it is the core, like it, everything around every large organization or every small organization is digital. And that is where people like me come in and help these organizations out. uh, so yeah, at best I'm a consultant. I drink coffee and I know things. So I'll start my presentation. uh, yeah, I think I'd rather try to keep it short and not overcomplicated. uh, I'll just touch on what Kafil would have said, and I'll just expand a bit on it. So when you deploy, right now, when you're talking about Docker containers, and how containerization helps you make your code portable, deployable, much more manageable, easy to explore, and move across multiple platforms without having to risk the functionality. or having to redeploy your containers, or get into all that hustle of uh, trying to make your code work, because it's a very common problem. You have your code and you try to run it on someone else's system, it doesn't work. So yeah, whatever be the case, containers solve that problem. But the problem at large organizations, or right, or even if you have like a very small project, uh, the problem starts arising when you have like these large number of services, right? So what these people tried to do, and where did this all of this start coming in? People started to build microservices architecture. And microservices, as you folks have might heard as a much more fancier word coming up, reading in post blogs, whatever, right? So let's say if you are to deploy, as a very basic example, if you are to create Flipkart, right? You could have like multiple microservices. Like there could be microservice for, say, the front page. There could be microservices that goes to the backend. There could be microservices that takes the payment, and there could be one that does the checkout. And there could be all of these like multiple services. Same for like Netflix, Uber, or any other application that you take. So when you now, each of these application components are like these, have been distributed and have been separated and isolated from each other. And all of these are being containerized at the same time. All of these are being deployed at the same time. Just for your reference, right? Google deploys like 2 billion containers in a week. And you can only imagine how much that is that. Every time you book an Uber service, the entire cycle from booking the service to the checkout or the payment, it is like 3,500 microservices coming in. And that is a lot, right? And all of these are in some format. These are again your containers. These are again someone's code that has been packaged into a container and has been running somewhere. And now when you are to deploy these containers, right, you have to connect them now, because, right, just as an example, when you click on that checkout button will take you to that front end service, will take you to the backend service that says, hey, this person wants to check this item out. And all of these services are talking to each other at the same time. That gets a lot complicated, and that is like one of the focus areas why we need things like Kubernetes in picture. Yeah, so basically, microservices basically are like smaller functions. Microservices are basically small functions, and for like every activity or every action that you do in your entire pipeline of your entire business flow, you create a microservices out of it, and it gets hard for people to manage all of that. Again, just another example of microservices. If you have like 3 services, you can split these services into 3 parts and have them run and deploy individually. One of the other advantages that you get out of this architecture is that you can have these 3 services. So users can be written in Python, threads can be written in Java, and posts can be written in, say, C++, C#, Go, whatever language, right? And all of these can still talk to each other, because you're in the end only exposing the REST API. And that is one of the advantages that you should focus on when building and deploying containers. But yeah, this is something that's pretty much possible. Another meme, just trying to explain what microservices are. Instead of one big application, you have like this multiple applications that are split into appropriate sizing. We'll touch on appropriate sizing somewhere later, maybe. Yeah, so as I said, even an older application can be taken advantage of if you have it running in a microservices architecture. Why a microservices, right? It becomes so much important. Like why microservices is the core or at center of my conversation here is because see, you can anywhere run a Docker container on top of a regular VM, right? You could do a Docker and map it to a port and have that service exposed somewhere. It's a simple task, right? That is not where the things start getting complicated. things start getting complicated when you have like millions of these services running in like 10,000 of these. So Netflix, for example, right? I don't know if you've seen that talk, but there are like tens of thousands of microservices running at the same time every time you're watching a movie, and it's hard, right? It's hard for like even an org like Netflix to make these manual connections every time something wants to talk to something, some service wants to talk to some other service. So yeah, so that is where things like Kubernetes come in. Uh, so a better way to deploy these microservices or these containers is to put them in Kubernetes. So what you do is that you take your container, you tell Kubernetes that you want to run this container, and it runs. I'll try to touch on the architecture a bit. Uh, yeah, I'll try to touch on the architecture a bit in a moment. But you could almost as if believe that today Kubernetes is at the core of every workload that you're trying to deploy. And people are moving to Kubernetes because of the advantages that it offers as a production grade orchestrator. Um, and I specifically want to highlight the point that Kubernetes is just an orchestrator, and that is at the center of what Kubernetes does. Uh, it's easy to get lost in all that wilderness of where Kubernetes comes in. It's a tough product. It's a good product if you have like complications, but it's also has like a steep learning curve if you want to get started. And it's hard. Like it's hard for you. It's hard for me. It's hard for everyone. Like even the people who created Kubernetes, it's hard for them. Um, and so that is right. Kubernetes, as people say, is the next Linux. It's the platform that will be running almost everything in the future, or as they claim, right? I have a different opinion. Things will get better. It's way too complicated today. It will get better in time. But yeah, you can almost take my word for it that Kubernetes is running everywhere, and more than 50 to 56% of organizations have already deployed some or other of their production workloads or their core applications of Kubernetes. Uh, why I am in absolute support of Kubernetes is that it runs best. It was developed at Google, right? So Kubernetes as a product, it was developed at Google, and it's inspired by something called Borg. Uh, so Borg is how Google had been running containers for the last couple of years in its premises, and that is how it was. Google as an organization was able to scale to to large planet scale organization without any boundaries, or being able to serve even marginalized people at low latencies or so. Uh, and that is where it has an edge. So even if you like deploying to GCP, right? GCP only has a certain edges against other cloud platforms. One is containerization, other is data analytics, and these are the only two areas, and that is where it has an edge, and it runs best on GCP. Uh, yeah, Azure has been catching up. AWS lags years or light years behind, I would say, in that front. uh, yeah, it doesn't work on Azure or Azure or GCP or Azure or AWS as much as well it runs on GCP. Yeah, this is a basic architecture of Kubernetes. I'll talk something about it. I think there are only a couple of people here, right? So like please feel free to halt me. I just want to bring this into picture that Kubernetes is an orchestrator. Again, I'm saying that Kubernetes is an orchestrator. It is basically a platform that says that provide a container to, and it will run your container for you, right? So everything with regards to container managing, where its storage is, uh, keeping the container running, uh, having the responsibility of scheduling it to proper nodes, on which worker node it will run. Everything else is taken care by container. I'll just talk about it a bit. uh, this is how the architecture looks like. You it basically control plane and worker node offer architecture. So you have this one server, Uh, if you're not sure, a server is just like this one big computer that has it's just one big computer, and the only task that it has is to like provide or run services that serve in a client server architecture, like a very high computing architecture, but that can run a lot of stuff at the same time and provide for like much masses. So yeah, here control plane is one server, and these nodes are, say, multiple, like two servers. You could count them as. Uh, you have a couple of things on the control plane, such as Kube API server, etcd, controller manager, and scheduler. Uh, every user that interacts with Kubernetes interacts with the Kube API server. The Kube API server talks to all of these components, and so, for example, if I tell Kube API server that I want to run this container, it'll go to, like, it'll try to make an entry to etcd. It'll not find an entry. It'll go back to Kube API server. It'll then tell controller manager that, hey, we want to run this one container, and you'll go back to scheduler. The scheduler will try to find what node fits in better here, and then it will try to uh, then scheduler will try to find a proper node wherein this container can run, and then run the container, and then you expose that container over some port and service, and that is how the end user can access this particular service. For example, if I have a web application, I tell my Kube API server that, hey, I want to run this web application. It talks to etcd server. It makes an entry that, hey, this person wants to run a web application or a website. Again, the same cycle. It goes to controller manager. It goes to scheduler. Scheduler finds out. It runs it on the node, and you expose that service on from that node as a part of your service, and then that's how users connect. Uh, all of this is complicated, right? So yeah, that is why you have Kubernetes. Like, it's just a silly joke, but yeah, one time I tried to explain Kubernetes to someone, and then we both didn't understand it. And that is true for like everyone, right? This is what I'm trying to do, but then that is what Kubernetes is, which is why I said it's complicated today, and it will remain complicated because of the architecture, but then it simplifies a lot of problems at a larger scale. So what do we say through all of these diagrams? Okay. I'll try to simplify it a bit, and just stay with me. In this diagram, right? Just focus on this diagram, and I'll try to take you through. Just halt me if you have like questions. And I know this is a stupid way to explain such complicated things, but this is also probably the most simplest way to explain these things. Focus on, there are three aspects here, and there are better diagrams or better memes down the line, but just try to understand. When we are talking about containers, right? I was telling to you about scheduler in this architecture. Talking to you about scheduler in this architecture. There's a scheduler. You can see a pod, and you can see a node. Just three things for now, and that is what I want you to understand here today. A core aspect, and that is a core aspect about Kubernetes, is the scheduler, and that is one of the most advantageous things that people look out for in Kubernetes. It's basically the idea that you as a user do not have to manage all of these services and networking and where this node would be scheduled. You really don't have to do it yourself. Otherwise, I as a person, or I as a system administrator, or someone who wants to deploy an app, or an application developer, will have to literally go out, find an application or find a node wherein this application can run, and then deploy it. To make it more simpler, say for example, if I have to install, say, Call of Duty on my laptop, right? It's as simple as trying to find a laptop that has enough space that I can install my game on, or any other application. So because it's such a large application, now I don't have to do it. The scheduler will do it. And that's what I want to take. That's what I want you to focus on right now. Scheduler's job is to understand where this application can run, and that is not my job now. So we are taking three things here. You have a waiter, you have a group of customers, and then you have a table, right? Your group of customers and every customer here. I will touch on what pods are, but I just want you to focus that every customer is a pod, uh, and all of these pods collectively form a deployment, right? All of these pods collectively form a deployment. Uh, what a deployment is? It means that even if one of these custom, okay, let's now these customers will be sitting on this table. This table is a reference to a node. This is and every customer has some needs. So this customer will sit on this table, and the waiter will serve the table, and the waiter will tell what that these customers can sit on what table, right? I mean, just as an example. So the kube scheduler will decide which of these containers or which of these containers can be placed on what table, right? So waiter is deciding what which of these containers can be scheduled on what table. Uh, you have a customer group, which is like a collective of these customers. So now let's say three people walk into a table, and so this cube scheduler will tell, this waiter will tell that you three are friends, you can sit on this particular table. And that is what essentially Kubernetes does at its core. It tells what containers can run where. So every customer is a container, and a group of you can have like multiple containers, and you can have like a group of multiple containers in one pod, and kube scheduler will decide what pod will stay on what node. And that is like at the core of it. uh, Explaining it in Kubernetes. So for example, you can have an application that is a web application, and if you want to directly integrate it with the database, you can have that database, and you can have like something like a logging service, something that takes all of these logs from these two services and does something with it and puts forward. So this waiter is right now deciding that, hey, these people, three people are together, they'll sit on one table. And if all of these would have been separate, again, it would have been a task for this particular waiter to decide where all of these services go. Uh, yeah, are you with me? Okay. So yeah, you simply do not run a container directly on Kubernetes. You deploy them as pods. So for each of these pods, right? For each of these containers, you deploy a pod. Pod is a set of containers that share the same namespace. To simplify it, it's basically a pod is a set of customers who sit on the same table, which is basically a node, right? What this also means is that a pod can also, a pod has a single IP address, and all of these nodes within each other share the same IP address, right? For the outside, for things that are outside that container, each and every one of these pods share the same IP address. By that also, it also means that it shares to every resource. So for example, if it has access to a storage, right, and if you mount a storage, all of these customers, now if you provide, right, now if you're on this table and if you keep food, now all of these people on this particular table can share the same food, right? You as as someone who's visiting a restaurant would not want to go to someone else's table to fetch, right? So that is why it is a separation. You could count it as a namespace, you could count it as a node. So like all of these containers are only accessing resources within among themselves. So a pod is the smallest unit of our workload in Kubernetes, which means that everything that you deploy turns in form of pod. Now, what this makes simpler is, right? Uh, Now you as a user are managing pods and not containers. Kubernetes, as we saw in this diagram, is taking care at the pods and not containers. And every time something dies, right? For example, pods are always ephemeral; they can die. But Kubernetes makes sure that at any point in time there are mechanisms to make that happen. But Kubernetes will make sure to keep that pod running or whatever it needs, or provide it some more space, memory resources, computing resources. All of that is done by the all of that is done by Kubernetes. uh, you could also say that like at every pod level you can define security constraints. uh, it's basically a smallest set of an application with multiple containers, uh, but all of them share same resources. So same IP address, same storage, or anything that you can think of. Basically, these two uh, at very core. So all of them share the same storage. Now, uh, what happens with Kubernetes is, and we'll only talk about like three primitive services in Kubernetes: uh, the pod, the deployments, and the services. So pod is the basic workload, and inside a pod you'll find containers running. When kube scheduler schedules a container, uh, it basically, so there's another service called kubelet. I'm not sure yeah, so there's another service called kubelet. This kubelet will start that container on this node. So it will wrap it up in a pod, and now kube API server is now always looking at this particular pod to make sure that this pod is running. It's basically kubelet who's doing that, but yeah. So Cube API server is always checking on that pod to make sure that pod is always running and it has the resources that it needs and whatever the status is. And if you want to delete that pod, again, you talk to Cube API server. This entire cycle runs again, and that's how your pod can be deleted. So if you want to delete or deploy a container, you deploy it in the form of a pod. Um, yeah. Now, if say I said that containers are ephemeral and containers can die, this also remains true with pods. Pods are ephemeral, pods can die. So to make sure that your pods are always running, you deploy them in the form of deployments. Uh, what advantages does it give you is that, say, for example, now if you're deploying, right, now if you're deploying a pod, and say, if you're updating a pod, or for example, one of your pod dies for whatever reason, maybe it ran short of resources, that particular node or that table that it was running on ran short on whatever resources that it needed, and the pod died, for example. So Kubernetes as a container orchestrator. Now here again, orchestration is the main is at the core. It means that Kubernetes is making sure that everything works well, and it's basically designing everything and making sure everything runs in order. Just think of it like, as an orchestrator, you can think of it as a project manager, someone who makes sure that things are running in place, but is not doing anything like on its own. So Kubernetes is basically a container orchestrator. So now, if the container dies, but you still want your application to be up and running. So if your pod dies, and then if you had told Kubernetes that I always at any point in time want 3 copies of this pod available, uh, you will always have 3 copies of that pod available. That's like at the core of it. That's at the core of it. So, and that it will make sure, so every time a pod dies, a new pod will be created in its place. And that's one of the advantages of Kubernetes, that you can always maintain a consistency in the number of workloads that you want to run. And right now, right, you can run like about somewhere close to, if you're deploying on GCP, you can run close to, right, 150,000 pods, somewhere close, right? And that's for a large amount of traffic, like so much traffic that you can serve like the entire planet at that scale. So that is a lot. And one of the other deployments, one of the other advantages is that you can keep on deploying to it continuously. So for example, if I have now, uh, again, taking example of Flipkart. Now, if Flipkart wants to update their front end application, right, they want to update their UI and they're probably testing. And I'm sure there are a lot of developers in this audience. Uh, so if you want to test your application, and it's a live application, for example, right, and you simply want to make sure that your application does not go down, because the only way to update your application is to, kill the previous one and deploy on a new one in its place. That's how it's been. With Kubernetes, what happens is that you can deploy it in the form of rolling updates, which is again an advantage. Wherein if you say that, I want to deploy this new application, I have a newer version of my web app, and I want to deploy this. The previous pods will be killed one by one. So one pod will be killed, one would be brought up. One pod will be killed, one would be brought up in its place. And it's usually the opposite. One is brought up in its place, and then the other one is killed. So like you will have like three pods up and running first, and then like three, and then one by one the previous three pods will die. That is one of the advantages. So you can always keep your workloads up and running without having to provide your customers with downtime, because downtime counts for bad experience and loss of business. Like you wouldn't want, right, if you have like a high revenue application. Just as an example, for example, say, right, you're trying to access google.com and google.com is not running because they're deploying something new in its place. Or probably you receive a lot of messages from a bank that they are trying to do some deployment, or they're trying to, this, whenever they say that it's scheduled maintenance, they're usually deploying something new. That's what happens, and that is like one of the perils of of a monolithic architecture, because every time you have to deploy, everything from scratch and from the start. So there's something like a downtime, and someone like me will go on a Saturday, spend this Saturday, instead of hanging out there with their friends on Saturday, Sunday, they'll go and they'll like sit through the night and day and simply change the application. That's just as simple. So that is like one of the problems that Kubernetes solves for you, that it makes sure that a new application can be deployed without having to provide your users with downtime, right? Eventually, in a rolling update, and that's what a rolling update format is, that a pod is created and then the previous one is killed, so that your users have a newer interface to like the new application. Um, and just by that, it makes sure that your application is always up and running. Last topic that I want to touch on is services. Kubernetes networking is difficult. I still don't get it. I'll be very honest. I still don't understand, and I'm sure that a lot of many people are like me. They will not understand. It is difficult on how these things communicate. But basically, you can have it in the form of, so services. What basically services are? Uh, what services are and is how you would access your application within that deployment. Now, when I said that these pods are ephemeral, uh, and they can die at any time, what it means is that you as an individual would not want to access these pods via their IP address. You would want to access it via some host name or DNS name. As an example, just think of it. It's always a better practice to run things by the DNS, because IP ranges behind that can change. For example, if you're trying to run google.com, right? Now, say there was no DNS in place and you always had to remember a set of IP addresses. Now, if the IP address change, you won't be able to access google.com anymore. But now, because you always remember google.com, even in the backend, Google might have changed that IP address a million times. You would still be able to access, because that is how it runs. So that is what services are doing here in Kubernetes. The services models, the services make sure that the deployment behind that pod, or the deployment behind that services, are always able to provide for whatever service is running in the backend. Uh, so if I say, for example, hit a URL for say myservice.com, just as an example, whatever pods have been deployed in the backend, right? I don't care what their IP addresses are. I will always get a response, and that is where my problem is solved. There's a lot to it, but I'll just touch on three scenarios. You want to talk within your cluster, so basically you want all of these services to talk to one another internally without having to expose them outside. So for example, right, you have a database application. Now that database application has a microservices, has a pod attached to it, and you want your uh, and has a pod attached. So you as a user or an application developer will not want to talk to the database directly, right? You would not want to have your database exposed to the internet, because that's a security risk. That's a major security flaw, and you should not do it. So you would want that only your web app can talk to, uh, only your application can talk to your database server, and your web app can talk to your database server. That's it, right? So what you do is that you uh, only create a networking model that wherein database server can only talk internally and not outside. But now here, if you want to take an example, you want to also expose that service outside. So now you also want that web app to be visible to outside people, outside this cluster, or outside this or outside these nodes, or to the outside world, to the globe, basically. So now how you would do it is that you will expose it. So when you make sure, when you're designing that all of these services only talk to each other, it's called as a cluster IP. That's where we're talking here. It's a cluster IP, right? But if you want to make sure that these services are also talking to services outside, or to users outside this cluster, then you expose it as node port. And at the core of it, with Kubernetes, there are only two types of services: cluster IP and node port. Cluster IP for talking within the cluster, node port for exposing it outside the cluster. There's this third kind of service that's called as a load balancer, and this came in popularity wherein, because all of these Kubernetes were being deployed in larger cloud computing platforms, and then people wanted a single interface wherein they can interact with these services or these deployments in the backend without having to expose them, or um, without having to have different IP addresses for all of these services. So which is why they created a third type of service, which is called load balancer, which does not come as a part of Kubernetes by default, unless and until you're deploying it on a cloud platform. So if you're deploying Kubernetes on your local laptop, you will not get something called as load balancer. It's not possible to deploy a service for load balancer. But load balancer is the third type of service, which is again that's something you can use to expose your cluster out to the outside internet. And again, it attaches and it creates like a real cloud-based load balancer. So whatever, right? If you worked on GCP, that three types of load balancer: HTTPS, TCP, and uh, SSL proxy. So it'll create a TCP load balancer, but it'll expose your traffic to the outside internet. Uh, and that is what load balancer service does. It basically creates a service, or a load balancer on public internet or on a cloud platform, and then it exposes that service to the globe. That's how you can do it. So this is like, again, a basic architecture as I was talking about. If I as a user want to interact with this website will only talk to this server, right? So here is a cluster IP, and here is something I can have like a node port or a load balancer, right? And this is us, they are talking to this service outside. That is how it's working. uh, yeah. So yeah, this is at a root a very basic architecture. uh, you have your traffic coming in from the load balancer. The load balancer will decide what node should this traffic go to. You have exposed this as a service, and it will go directly to pod. The pod will again respond in the client server panel, and it will go all the way up, top down. So again, basic OSI model, but here you have that load balancer deciding which node will it go to, and so on. So that is like basic Kubernetes. I think I've touched on almost all the components. I'll just revise through it. Uh, First is microservices, because you're basically slicing services down to the to the proper sizes, so that all of these services can talk to each other, and they can be maintained and managed individually. With microservices, you get the architecture starts getting a lot complicated, and then you have to maintain all of it. Like you have to organize all of it, structure all of it, uh, have them talk to each other, which is why you need something such as an orchestrator, which is where Kubernetes comes in. With Kubernetes you have like three components. Now Kubernetes as an orchestrator will make sure that everything runs in order and is in place as you want it. And it has three basic components as at the very core at this level. uh, there are pods, there are deployments, there are services. Pods are the basic unit of how your workloads would run. Uh, pods have container inside them, and Kubernetes only takes care of pod. The pod takes care of the container. Uh, yeah, you have pod, and for every pod, you have that pod, and pod is what serves your traffic. Now, if you want your application to be up and running always, you create multiple copies of that pod by deploying a replica. By creating its replicas and creating a deployment out of it. So when there are multiple copies of that pod, and you can have them as a group in a form of a deployment, and then the deployment makes sure that there are always a certain number of replicas always running, and that every pod exists, right? Even if a pod dies, there'll always be a copy. Now, if you want to expose all of this information, all of this application via some communication channel, you will create a service. And there are three types of services. There's cluster IP, there's node port, there's load balancer, right? Cluster IP to talk within the cluster, node port to talk outside the cluster, and load balancer if you're talking outside the cluster, but you want to have like a single IP for the entire service. And this is only available on cloud platforms. This will not work in your local system. So yeah, that is what Kubernetes was. I know it's pretty complicated, and it honestly took me like over a year to just like clear those certifications, whatever I decided to do. You can like go on and take that route. I don't think it's worthy. Like nobody would be doing CK and CK 83 years down the line. I'm pretty sure of that. Yeah, that was my presentation. And yeah, if you want to join GDG Cloud New Delhi, you can log into this page. I can be reached here on LinkedIn and Twitter. This was a means as a service, and may the pot ever be in your favor. Yeah, I'll stop. I don't have a presentation, but Piyush asked me that, and of how I got into cloud computing. So yeah, I'll just touch on it. And so yeah, I just want to share my experience. I was working at a very large multinational organization, right? I was working for Siemens, and Siemens is a great organization, right? If you want to work, if you want to have like a very relaxed culture, people are respectful. But then I was also young, and I had things that I could do, and I had like the first-hand experience of working out of a data center, and that is where, right? It was back in 2015. Things were escalating, and this is where we are talking about that. I started my presentation with saying that digital is what the organizations are doing today. They don't want to do anything else. Digital is at the core of their strategy. They don't want to pursue or like keep it as a side, because earlier IT was an enabler. It was like, hey, everyone's doing IT, let's do IT. Now everyone is like, if you don't do digital, you're dead. It's as simple as that. So that is what was happening, with at least that's what I thought. Siemens is a growing organization, but then when you have an organization with say 450,000 employees, it's rather hard to grow. And then it's basis experience, right? A lot of these organizations have a lot of senior people in them, at least I think you would also relate to it. In our parents culture, it's a thing to stay loyal to an organization, right? Which is why you have all of these government employees, or these employees working like 40 to 50 years for an organization, 30 years, like you would say that someone is working for this Accenture or these reliable organizations, because these organizations have a very simple and static culture. And they grow, but they only grow financially. Like the people don't grow. People have been sitting for like years now. They like have very basic tasks to do. and their skill cannot be counted anywhere. Like if these same people were to go out and find a job, I'm doubtful if they will get it. Uh, and so it's hard for these larger organizations to bring about a change. One of the other things that I like about working in smaller organizations, and specifically choose to stay in a smaller organization, is because there's you can grow a lot. So that was the problem with Siemens, and at its core of its technology, right, they had this data center that they had built over, say, a couple of years. They had like hundreds or thousands or hundreds of servers, in always an air conditioning environment. Interesting experience for fun, but not for your career or your technology sake. Uh, there are a lot of hassles in managing, and as I was saying, right, I had to come on a Saturday to simply deploy something new, and all of that was a challenge. And I didn't want to do it, right? Who wants to work on a Saturday when your friends are hanging out or something like that? And then the deployment cycles were harder. People were it was hard to get across silos, and probably Kapil also talked about it, that development and operations were two different sets, and people were always playing volleyball among it, or tennis among it, and always saying, it's your ball, you keep it. uh, and just simply throwing off. People were all quarreling, fighting, everyone saying that it's your thing. I, as a person, simply thought that there could be better ways to do things. I was always interested in technology. To be honest, right, I also graduated out of a pretty mediocre university, so I really had like no clue where to get to. But I was always interested in computer architecture, because that was what something interested me, and I could not code, right? So that is like an important point. So I was not into coding. I did not understand. I tried my hands at data science. Still don't understand NumPy. Like I can't get across like two numbers in arrays, whatever. Like, and like it's something that I've thought of I'll probably do in my life. I'll probably try data structure and algorithm, but no, I still don't understand what a linked list is or how you can code it. I mean, I know what linked list is in theory, but I don't know how to code it. And it's as simple as that. And but I was very keen and interested in computer architecture, right? The only kind of maths that I aced in my college was digital, was binary algorithms or binary mathematics. So I could very well do, calculate like how all of these architectures connect, or calculating what 32-bit architecture would look like, explaining people how a processor works, all of that lectures in microprocessor or something like that. That is where I found my forte in. I simply like to put stuff together, and that's probably, I think, I got into networking in the first place, and all of that physical stuff interested me, because I could see that there was, and for me it was like Lego pieces putting up together and growing from there. So that is where what I thought that I could do at I that is what I thought I could do. um, I liked putting architectures in place. So yeah, I got tired of Siemens, to be honest, and that is where started. Like Google Cloud, I'll honestly say, right, it just felt like a calling. It just felt like a calling. um, I was studying for Ansible because I wanted to automate a lot of stuff within Siemens, and again, that was out of my own initiative, because again, they were very keen on doing things manually. One of the things that these people also do in organizations, if you are in an older organization, is to keep things doing manually and not share that knowledge, because that protects them for their job. Like people don't want to let go of their job, or rather move to the next stage. So they loved it. So I was studying Ansible, and Siemens sponsored for my first year of Linux Academy subscription. Um, I completed my Ansible course, whatever I wanted to do. Then I started pursuing Google Cloud Platform, again from Linux Academy. Um, I spent about a year studying this. Got pretty hands-on, got a good knowledge. I would spend like every Saturday and Friday, Saturday, Sunday studying GCP. And there was like this one time I thought that, hey, I was actually about to jump ship and said, I mean, like, just drop this, let's do MBA. That was as super as an idea that I had. And then I thought, if I have been in technology for 2 to 3 years, why not pursue this? So I talked to my cousins about it, and the conclusion that we came to was that, let's just pursue technology. If it doesn't work out for you, yeah, you may as well switch. So that's how, like, my aim was to crack like all the three certifications at that time. That was like there were only two certifications when I started. By the time I was finishing, there were three. So I completed two of them. The third one that I decided, which is the data engineering one, I still could not pursue, and I still haven't done it. I'm just lazy that way. So I just completed my certification, started looking out for Google Cloud jobs. And if you still see in the market right here, even today, till today, it's very hard to find people who are Google Cloud certified and have like had good experience with Google Cloud or have good knowledge on Google Cloud. Like you'd rather find people on AWS and Azure. I just felt like, if nobody's doing it, I'll do it, because again, I also wanted to leverage that first mover advantage. And if you see my certifications, it's like the architect one is under 4,000 people, the associate engineer one is under like 400 people, the developer one is again under 400 people. Uh, and so that's like one of the things, right? People look out to. Uh, the lower your series ID, the more recent your certification is, and more early you could crack it. And that's one of the testaments of how much of your experience is with Google Cloud. So I got a Google Cloud job with a startup. Worked for it like a couple of months. The startup went bust, and here I am at Media Agility, wherein I kind of whatever experience that I gained over the years, try to guide people through whatever the challenges are, and yeah, helping people or organizations develop their careers or so, or sorry, develop their business or so. Yeah, that was it. Any questions? Yeah.
I guess there are some. Okay, in the personal chat, one asked me like he wants to pursue ML ops. So, any tips?
I think it's just a fancy word. I think it's a fancy word. Uh, See, yeah, I would acknowledge that there are challenges with managing machine learning based model, and if you want to iterate over them, they mostly people what they want to look at is something like Kubeflow or something that wherein they are able to manage their machine learning platforms iteratively, and and still have control over them, have version control over them. Uh, I think one of the things that you can start looking at is Kubeflow, but I won't suggest you again. I would suggest you advise you against it unless you have like still, uh, unless you have some experience of machine learning, right? Because every time you have to train that model, you will deploy that model and that will run. So start with something called as Kubeflow. Google Cloud has again good documentation. It's an open source. Uh, it's an open source platform. Yeah, pursue that, uh, and you can also easily get started with it. Basically, creating models and deploying them to a container, and then you can serve that model. One of the advantages that you can do with MLOps is like you can have multiple models running at the same time so that you can test your results, and then you can manage them in a better fashion. But there is no as such technology for MLOps, right? It's a methodology that people call it, and it's again, I would say it's just a fancy word. It's just DevOps, but for machine learning based workloads. It is difficult because uh, the model has to serve itself. It's not as simple as deploying a web app, coding it. The training time is also incorporated, or the evaluation, the testing time is also incorporated in it. So yeah, I would suggest start with Kubeflow. That should be your ground zero, and then you can build everything around it, whatever pipelines that you want to build, ETL pipelines that are needed, all of that will come in a part of it. So yeah.
So, I hope Joy gets the insights of the ML ops and its request is to like Joy, you can start on as Pranay sir said that you can go with Kubeflow for machine learning and just kind of ML is a fancy word for it. Uh, so before ending to the session, I congratulate my entire team like Lakshay, Aryan, Kriti, Isha, Arendra, and Anubhav Bhaiya, and the entire design team who designed the posters and for the meeting today. And let's give a shout out to our like collaborative members, Akansha Raghav. She's a Microsoft student partner, and Aman Rawat. And there is one more named Himanshu Singh as a GitHub campus expert. Thank you so much for the collaboration, and kudos to you guys. And thank you so much, Pranay sir, for joining us today and giving such an amazing session on Kubernetes with the full of meaningful. Yeah,
Yeah.
that was the word. Uh,
Yeah.
there is there is a question from Gajanand. Is Kubernetes safe? And which one will you prefer, Kubernetes or Red Hat OpenShift? And if you want to go for certification, do I go for CKA or Red Hat OpenShift?
Um, yeah, Kubernetes is safe. Kubernetes is 100% safe, and I would definitely suggest you to go for Kubernetes. See, and I'll just give an example. When I did my certification for, say, Google Cloud, when everyone was doing AWS, the idea was to have an early stage advantage. But no, if you go for Kubernetes for OpenShift against Kubernetes, I think that would be a disastrous. Uh, it won't help you as much as a CKA certification would. You as a if you're a student, I would say you could pursue it. I would honestly advise you against it. I would rather suggest you start off with basically learning how to deploy basic pipelines. But yeah, if you want to go for that route, take the CKA route. It will be difficult, but it'll be worth it because that's what people are looking for. There are like more than 24,000 people certified right now with CKA, and India is like a very competitive market, so you like have to find your place. But there are a lot more use cases for CKA than OpenShift because like on a lot many cloud platforms as well, you get a managed CKA service and not a managed OpenShift service. With OpenShift, you'll rather be locked into IBM's ecosystem, which anyway nobody's using these days.
Okay, I got. And I hope it answers to you. So wrapping up the session. Uh, thank you so much, sir.
Yeah. If you
Thank you.
want to learn, just last one thing. If you want to like learn or get started with cloud, if you want to pursue certifications, yeah, subtle pitch, but yeah, Cloud Community Days is coming next month,
Yeah.
in December. So we're organizing everything around certifications. If you stick around, answer a couple of questions, we'll also sponsor your certification, and that's what we're looking at. We have a couple of surprises for you there. I hope it pans out well. Um so if you're looking to start off your career in cloud, Cloud Community Days will be all about how you can pursue your certifications and why get certified. What does your career path look like? And you'll have a lot of insights on how you can make a career in cloud. It's specifically designed for your careers.
So do make the note of the dates, 22nd and 23rd December.
Yeah. Thank you.
Thank you so much, sir, for joining us. Thank you so much,
Thank
audience,
you.
for
Bye.
being a patient to our audience to us. Thanks so much.
Bye.
Bye bye, sir.